let's start with the first one. All right. Now I'm gonna explain things of how we're going, and then slowly we'll just go a bit quicker. So the first thing is, so the printed output of the below code lines is, so here we've declared and we've initialized a equal 5, and we have x declared. Then we have x equal a minus minus plus minus minus a plus 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 a, and then x. So this is divided equal. I can write this as x equal, right? X equal x divided by a. So there you go. Now, why am I reading the whole thing? I always suggest you always try to read the whole thing first, just because it could be a trick that's wasting your time, where all this is kind of redundant, and I might be printing something completely different, right? I won't say this is a common occurrence, but it has happened before, and so it's always best to just read the whole thing to make sure that there's nothing that you will be doing that is useless. So let's start. As you remember, these are prefix postfixes. So the prefix, right, is we use the value, then we change the value, then we use the value. The postfix, we use the value, then we change the value. All right. So we can see it here when we say a minus minus, because this is a postfix. It's coming after the variable. We're going to use the value, which in this case, let's keep a tab of the values. We have first a equal 5, so we're going to say x equal 5, right? Now that we've used the value right here, we're going to update the value. Now it's a minus minus, so it's going to be equal to 4, right? So I used it, then I changed it. Now here, I'm going to have a prefix, so I'm going to change it, minus minus, so this becomes 3 because it was 4. 4 minus 1 is 3. Minus minus becomes, so now that I've changed it, I'm going to use it, right? And then same thing here, we have a prefix, so I'm going to change it, then use it. So this is going to be 5 plus 3 plus 4 will be equal to 12, right? Then we're going to do x divided by, x equal to x divided by a. What is the value of a? Right here, it is 4, right? So 12 divided by 4 is going to be equal to 3. So the new value of x, so I'm going to write the new value of x here is 3. And then they're going to tell us to print here x plus a. So what is x? It is 3, right? What is a? It is 4. So 3 plus 4, we have 7 right here. I'm just going to make the answer in pink. Why not? 7. All right. We can check it in the solutions. 7. So we're good. Let's continue. Then we have this problem right here. Very similar problem. Again, quick check. We're using all the variables, nothing redundant. Immediately, I've declared and initialized 3 variables, and we've initialized them. We've given them values. Right? Initialization means we've given a value. Declaration is just we said, hey, this variable exists. So int u is a declaration. Int u equal 8 is a declaration and an initialization. So v++, again, this is a postfix. So what am I doing? Right? I'm gonna first change the value of v. Sorry, I'm going to first use v. So I'm going to say v is equal to currently. Now in this case, it doesn't matter because the using and the changing, it doesn't matter just because it's alone. So immediately I could say v++. So that means v will now be equal to 5. Right? We just changed the value of v. We did not use it to change anything. Right? It's not altering any other variable. We're just using it alone. Then we have v equal minus minus w. Now here a lot of people were confused. Okay, what am I doing here, right? Java is reading from left to right. So what is Java reading? It's going to first read the v equal. Okay, so it's saying, okay, I'm changing the value of the variable v, right? And then it's going to say minus minus w. So it's going to read minus minus w. So what is this minus minus w? It's reading, right? It is reading the prefix, then it's reading w. So what is it going to do? What does the prefix do? It changes the value, then it uses it. So I'm going to have to change the value. Right, I'm going to have to change the value. So w will be equal to what here? It will be equal to 7 because it was originally 8. And then I'm going to use it. So now this will be plugged in. And v will be equal to 7. All right. Now, what would have happened if, let's say, I did this? I did v equal w minus minus, right? What we're gonna do is, again, v reading left to right, I'm gonna say v equal, I'm changing the value of v, w minus minus. So this w minus minus means that I have a postfix. So what am I gonna do? I'm gonna use then change. So now I'm gonna say v equal to, what is the value of w? Let's assume we don't have this right here. This didn't exist, right? I'm based on the initial condition. W equal 8, so I'm gonna V will be equal to 8, and then I'm gonna change. So W will be equal to 7. So again, this is where the prefix postfix. This is why this and this are not equal. So they're not equal. These two things. Okay. Now we're still on the condition. We got V equals 7, and then we have W plus equal. Okay, again. W plus equal means that we're gonna say that it's the same as saying as W is equal to W plus U times 2. All right. Now W in this case is what? 7 plus what is U? U is 8, 16. So this is equal to 23. All right. Now if I add these up, I have 7 plus 7. That's 14. 14 plus 23 gives me 37, right? So the answer is going to be this right here, 37. So let's check it out. And 38. Let me just check. Did I do my math correct? Sorry, U is equal to 8. My bad. Yeah. U did not change. We never changed the value of U. We never altered the value of U. So it's going to be, so W here is 23. Right, so it's 23 plus 7 plus U, which is 8. So it's going to be 15 plus 23, which is 38. My bad. Okay, so yeah, these types of mistakes can happen all the time. So it's always best to kind of keep track of all your variables. So I kind of lost U here. So it's always best to keep track of all your variables, write them down in a neat way so you just don't get lost, especially if it's a bit more complicated than this. Now, let's check out this one here. Okay, we have 55, 27, 23, right? Double D equal, this right here is a casting, right? We're casting into float. All right, so is this going to be a problem? Yes or no? Since float is 32 bits and double is 64 bits, I can widen from double to float. So I can go, from float to double. So I can do this. I can go from float to double with no problem because I'm widening, right? I'm putting a small box into a bigger room. So I have no problem. And so this is exactly what we're doing here. So down, we are casting. So right here. We are turning whatever value we get from here, we're turning it into a float. We're saying, hey, become a float. But then we called it a double, right? And so because I'm widening, I'm saying this float becomes a double. There's no problem. I can turn the F, the float into a double with no problem just because the double has 64 bits. The float has 32 bits. So I'm not narrowing, which is perfect. So let's go on and try to solve it. So we need to find B, the value of B, and the value of D. Immediately, I see the only thing that will change the value of B is this plus plus right here. So this prefix is going to change it into, because it's a prefix, I'm going to use it. I'm going to change it, then use it. So the change will turn it into 28 because 27 plus 28, 27 plus 1, sorry, equals 28. So I'm going to input here, B is going to be equal to 28. Again, I'm scanning immediately and I see that there's nothing else that will be changing the value of B. So I know that B will be 28. All right. Now, I'm going to continue. So it's 28 plus. This sign is the modulo. So modulo is going to give me the remainder. So here I have 55, all right? 55 modulo 4. All right, very quickly, if I know I have 40 and I could add 52. So 52, basically, I know that 52 is a multiple of 4, right? If I try to go any higher, it will be 56. So the highest multiple of 4 I can get is 52. And what will be my remainder? I'm going to have 3 remainder. So I'm going to have 55 modulo 4 basically means what is my remainder. So if you remember like the old division that you used to do where you would divide so that you'd only get whole numbers and you'd keep a remainder for whatever you couldn't divide. You wouldn't do decimals. You wouldn't do fractions. You'd keep the remainder. So exactly here I need this remainder, and this remainder is going to be equal to 3. All right. Now let's do the final part, which is B divided by C. Now, since B over C, B in this case is 28, right? So it's going to be 28 and C is 23. Now, both of them are integers, right? Because they're both integers, I'm going to do integer division. So 28 over 23 will actually give me 1. right? What if I had any of these, if any of those was either a double or a float, then I would have had like the division that we know, and I would have had to search what 28 divided by 23 is, which is around the lines of 1.68, something like that, right here. 1.26. So 1.26 something. But we don't need to do that. Why? Because 28 divided by 23, both of them are integers. So I'm going to get an integer at the end without any decimal points, right? Again, if I had 28.0 divided by 23, the answer would have been 1.26. If I had 28 divided by 23.0, it also would have been 1.26. But because here, both of them are integers, I'm going to be left with 1. And again, in this case, if you forgot and you were a bit confused immediately because you're getting a fraction that is a bit, you don't know how to solve, right? And the quiz does not allow for any calculators, so your eyebrows should be raised at this point. Okay, so 28 over 23, we're gonna get 1. So the whole result is gonna be 28 plus 3, that will give me 31. 31 plus 1 is 32. 32 as a float will give me 32.0. Let's check the answer. Oh, sorry. And 32.0 and 28, perfect. So let's go down. Now we have this problem, double R. Again, here we have a declaration, then we have an initialization, we have some type of multiplication, and then we have casting again. So casting is always, it's kind of forced, you're changing the, or what this, the type, the data type of this variable, right? So we changed it first to an integer, then we changed it to a double. So let's go on and try to, in this case, you might be thinking, hey, I'm moving from left to right, but double int, what does that mean? Am I casting the int into a double? That doesn't make any sense. So I'm going to have to, first I cast the int, I cast the A, then this whole thing is cast as a double, right? So that's the way we operate. Mistakenly erased, no problem. Okay, so let's just do it very quickly. A equals 3.146 times R times R. This will give me, if R equals to 10, then I'm going to get a result which is, again, in this case, A is a double. So the value of A will become 314.16, right? Now I'm going to system.out.print 1. So this one is going to give me, again, since here this is a string. So I know that my output will start with a 1 because this is a string. And now I'm going to go through this. So first I'm casting the A, which is a double, into an integer. So, and now you need to remember, when I cast an integer, a double into an integer, what will happen is I'm going to get rid of these decimal points. And so I'm going to be left with 314. Right? I'm just going to get rid of them, just delete those these decimals. And then once I turn it into a double, what's going to happen is I'm going to add a 0.0 because now I'm turning 314 into a double. So it's going to be equal to 314.0. So my end result will be 1314.0. This is it. We can check our answer. 1314.0. Perfect. Now, number 6, we have a float. X equals 61.2. Again, there's no difference between a float and a double. So don't be, don't panic. But this F, again, this F is not part of, this is just signified that this is a float, right? This is a special way that you must add whenever you're doing a float. You need to add this capital F. Then we have a long. Again, we're using kind of unorthodox types of data types. Instead of integer, we're using long. Instead of float, we're using double. And then we're using int z equal int y. What does that mean? So we've defined, we have a different variable. It's called z, and it's equivalent to the casted integer of y. So what's y? Basically, I'm turning this into this 12. Now, if I go up very quickly and I check this here, the long actually has more bits than the int. So it's 64 bits compared to 32 bits. Do I have a problem though? No. Why? Because the number 12 fits in both. So it fits in both, so I don't have a problem. Now, would I have been able to widen this? Would I have been able to do it automatically? No, this conversion wouldn't have happened automatically, but through casting, right, I'm able to force that, and it works. Why? Because 12 is both in the 64-bit and 32-bit range. Right? It's even in the 8-bit range. But if my number was so huge that it didn't fit into the int, then I would have had a problem. But in this case, because 12 fits into the int, I have no problem. right? So okay, so I have now I've set this an integer equivalent to 12. Now we're gonna say x is gonna be equal to int x minus 1. So immediately I'm gonna be casting x into an integer. So I'm gonna get rid of this 0.2. It's gonna become 61 minus 1, which is equal to 60, right? But what is the type of x? Now we gotta always remember x is a float. So this 60 will actually be 60.0. Right? Because we did not change the data type of x. Here we did cast it, but that doesn't change the inherent value of x. It just, this has it modifies it, but it doesn't change the value of x. It's not like the postfix prefix, which actually changes the value. It just modifies it temporarily for this line. So we get 60.0 system.out.print y++ minus plus y plus x. So again, y++ in this case, we have y is a long, which is going to be 12. Right, and then we change the value, y will be equal to 13 minus, because plus y, so y will be equal to 14, again prefix, so 12 minus 14 plus, what is x? X in our case is 60.0, so 12 minus 14 is minus 2, so I'm going to get 58.0. Let's check the answer. 58.0, perfect. This one I think you'll be able to do on your own, and then let's finally do this one. This one is kind of the big boss, the final boss. A equals 5, b equals 2, c equals 3, d equals 4. Let's do the result. Okay, first of all, immediately the result is going to be equal to, I'm going to shorten it, I'm going to call it r, is going to be equal to d. So I'm going to make them all in different colors. We said d is equal to 4, so I'm just going to say 4 here, all right? 4, let's see, plus a minus minus. So because this is a postfix, a minus minus is going to be 5. And what will be the new value of a? I'm just going to write it here. The new value of a is equal to 4. The new value of a is equal to 4. Then multiplied by minus a. So that will change it. So here I'm going to do a multiplication. What's minus a? Because it's a prefix, I'm going to change the value before using it. So it's going to become 3. And then here, there's nothing, so it's just going to be 3 again. Plus, I'm going to change again to indicate plus minus b. Again, this is a prefix, so what's minus b? B is equal to 2, so minus b will be equal to 1. So here I will have 1, right? And then so I have minus b modulo plus a. So this modulo here, I have this modulo here, and plus a, the new value of a is going to be equal to, actually let me keep it in blue just so everything tracks. The new a is, so we had the old a is 3, becomes 4. So how many, 4 does not fit anytime, so 1 modulo 4 is going to be, this is going to be equivalent, I'll make it in green, this is going to be equivalent to 1. Here we have 6, then we just follow PEMDAS rules, 4 plus 5 times 6. Plus 1. So 4 plus 1 is 5. 5 times 6 is 30. So we have 35. So our result is supposed to be 35. A, our final value of A is 4. C, which we actually never used, is 3. B is, we did the minus, so it's 1. And D is 4. It was never changed. So let's check. We have 4, 1, 3, 4, 35. 4, 1, 3, 4, 35. Perfect. So that's it. See you guys on the next one. Bye.